Yo, this is Coach Ray back at it again. Today we are solving quadratics by factoring. First line you see up top, standard form. We've talked about that in previous notes, but A, B, and C are usually numbers, and this is what quadratic equations normally look like, standard form. Okay, below it you see factored form, where A, P, and Q are normally numbers. And you have factored before. So you have taken quadratics and made them look like this form before. That is not new. We did a whole unit on factoring. Okay, so most quadratics break down to be two binomials like this. This A out front, you've done this as well. Greatest common factor. Every once in a while, if you think back to when we were factoring, every once in a while you looked at all the terms and you saw like, oh, they're all even. So I can factor a 2 out of each one of those and put that 2 out front. That's the only situation where you would have an A out front, is if you factored something out and let it show out front. Okay, so we'll talk a little bit more about that. But this is factored form. So if we look at example 1, clearly it's already in factored form. Example 1 is not even giving it in standard form and making us factor it. They factored it for us and gave it to us in factored form. Okay, when it's in factored form, it only takes like basically one more step to solve this equation. All right, but in order for me to explain to you how this step works, I kind of want you to just look at this randomly. If I had something times something equal to 0, which is essentially what I have here in example 1. I've got 3 times this whole something, this binomial, times this whole binomial, which is something equal to 0. So I'm going to ignore the 3 for now, and I'm just going to call the first something x, the second something y, because they're two different somethings. Okay, so if I had something times something equal to 0, one of those has to be 0, correct? Okay, if x equals 0, it does not matter what y is. This sentence is going to be true. 0 times whatever y is going to equal 0. And that's what solving is. We're trying to figure out what is a number for x that can make this a true statement. Okay, isn't it also true that if I make y equal to 0, no matter what x is, this sentence is going to be true. Something times 0 is going to be equal to 0. So these are both solutions to this math problem. Okay, now, knowing that, let's come back up to our problem here. Knowing that, I've got 3 times something equal to 0. I can just set each something, x minus 4, equal to 0. Because if that something equals 0, then I know this is going to make a whole true sentence. This something, my 2x plus 5, equal to 0. If that something is equal to 0, then I know this is going to make a true sentence, because when it multiplies by other stuff, it's going to equal 0. Right? It's even true to set 3 is technically a factor here also, because it's 3 times this factor equals 0. It's not wrong to set that factor equal to 0. It's just dumb because that doesn't make sense. 3 does not equal 0, so we don't even really bother with that. And here's what I want to tell you. People always ask me this question. Mr. Ray, when I'm solving quadratics by factoring, does that 3 just disappear? Not really. The 3 just does not affect your answers. And that's what we're looking for. We're looking for solutions to this math problem. The 3 does not affect those solutions. That 3 affects the graph. So the next set of notes on the next lit YouTube video I put out, probably next week, we'll be graphing, and that 3 will affect your graph, not the solutions. Okay? So for now, I'm even just going to erase it because it's not going to affect the solutions that we're trying to find. All right, so back to this. I said this something equal to 0. I said this something equal to 0. Now I just solved them both. This one had 4 on both sides. So I get x equals 4. That is a solution to this math problem. This one requires a little more work. Minus 5 on both sides. 2x equals negative 5. Divide both sides by 2. So my answer is x equals negative 5 over 2. Most quadratics have 2 solutions. We talked about that when we did quadratic formula. Okay, so this problem has 2 solutions, x equals 4 and x equals negative 5 over 2. And here's what I want to show you. Don't forget, when you're solving an equation, what we're looking for is something that I can put here and here for x to make this whole thing a true statement. Let's look at 4. If I put a 4 right here, I would get 2 times 4 is 8. 8 plus 5 is 13. All right, fine. And then when I also put it over here, 4 minus 4 equals 0. So 3 times 0 times 13 is still going to equal 0. So that makes this a true statement. If I put negative 5 over 2 in right here, 2 times negative 5 over 2 is negative 5. Negative 5 plus 5 equals 0. So no matter what these other stuff is out front, because I'm going to multiply by 0, it makes it a true statement. Everybody okay with that? Okay. Let's keep going. Example 2. Is example 2 in factored form? Obviously not, right? So I'm not ready to set my factors equal to 0 yet. Is it in standard form? No. No. We need our x squared, our x, and our constant all on one side, and then we need it equal to 0. Okay, no problem. Plus 20x, plus 20x. I got 4x squared plus 20x equal to that canceled, and all I have left over here is equal to 0. Now is it in standard form? Kind of. What are we missing? The constant, c. Okay, so we obviously have ax squared plus bx. We just don't have a plus c back here. I can't force there to be a c back here. If there's not a c, there's not a c. This is the same thing as 4x squared plus 20x plus 0. Okay, and we just don't need to write the plus 0. So there technically is a c, you just can't see it because it's 0. All right. I've asked this question all day. No class has got it right yet. I've had to tell everybody. What method of factoring are we going to use to factor 4x squared plus 20x? I want to ask it one more time. What method of factoring are we going to use to factor 4x squared plus 20x? Say again? We're trying to put it in factored form, but I'm asking what method are we going to use to get there? No. Someone said distributive. It's the opposite of distributive property. Anybody remember what it's called? I think we called it undistributed in class or something weird like that. GCF, greatest common factor. If there's stuff in common in all of them, you can pull it out front, and it's kind of like the opposite of distributive property. So, and I noticed that just because I see that they both have stuff in common here. So a 4 is in each, so I can pull a 4 out. There's 2 x's in the first term, 1 x in the second term, so the most x's I can pull out is 1. Okay, and then I'm going to put my parentheses, and after I took that stuff out, I'm going to just write what I have left. Okay, so I took a 4 and an x out of this first term, which means all I have left is an x. Okay, 4x times x, using that 4x squared, opposite of distributive property. To get this positive 20, I'm going to need a positive 5. So 4x times 5 would give me that 20x because I took that x out, so I'm good. I have just factored the blue line. Although there's not 2 sets of parentheses like there was in example 1, this is still factored form. If you want, feel free to write it like this. Okay, we just didn't need it because 4x is a monomial, not a binomial. If it was a binomial, we would definitely need 2 sets of parentheses. All right, so now that it's in factored form, I just set my 2 factors equal to 0. 4x equals 0, and x plus 5 equals 0. And I solve each one. First one, divide both sides by 4. 0 divided by 4 is 0. That is a perfectly fine answer. Don't be afraid of that. It's not undefined. It's not anything weird. It's not no solution. 0 divided by 4 is 0. That's a number and an answer. Okay, this one, I've got minus 5 on both sides. So I get an answer of x equals negative 5 over here. Hey, so if I put 0 in both places for x, it would make a true statement. That one you can see pretty easily. If I put negative 5 in both places for x, it would make a true statement also, which is interesting. Here in front, negative 5 squared would be 25. 25 times 4 would be 100. Back here, negative 20 times negative 5 would be 100. So 100 equals 100, true statement. All right, moving on. No. All right, example 3. And I can move it back up if you need to copy stuff as soon as we're done. Example 3. Clearly not in factored form, right? So we're not able to just set them equal to 0. Question. Yeah. Clearly not in factored form, so we can't just set them equal to 0 yet. Is it in standard form? No. Almost, so no problem. Okay, just my 5x is not where it needs to be. So I'm going to go minus 5x minus 5x. So I've got x squared minus 5x minus 24 equals, that's gone, so I've got equals 0. Now it's in standard form. Once it's in standard form, I factor. how you factor quadratics, review back from our factoring unit. How I taught you to factor quadratics is the area model, which I called like rooms. We found the area of rooms, or some people just call it boxes, or science calls it Punnett square. Okay, and just a memory refresher on factoring quadratics. In this box goes x squared. Okay, so how did we get x squared as the area of that room? Probably x times x. What gave us x squared right there? Okay, negative 24 goes down here. I deal with the signs at the end, so I'm going to just kind of treat that as a 24 right now. So to get the area of that room, I'm going to guess what multiplied to give me that. Could be 1 and 24, could be 2 and 12, could be 6 and 4, could be 8 and 3. My advice is always to guess the numbers that are closest to each other, but that does not always work. One of my students is telling me to guess 8 and 3 for some reason. I will guess those. All right, so now I got to fill in these other two rooms. 3 times x gives me 3x in this room. X times 8 gives me 8x in this room. Now I need to look at, with those two blue rooms, can I make a negative 5x out of 8x and 3x? Absolutely yes. If I make my 8x negative 8x combined with 3x would give me the negative 5x. Beautiful. So if that needs to be negative, I need to make my 8 negative. So now x times that negative 8 gave me that negative 8x. So just real quick, here's what we did, just so we're clear. We figured out that this guy times that guy equals x squared minus 5x minus 24, which is in the middle. And that's what factoring is, taking something and breaking it down into two things that multiply together. All right, so let me write these down. I've got x and positive 3, and you could have written these in either order. And I've got x and negative 8 equals 0. I'm in factored form, yay! Once I'm in factored form, I just set each factor equal to 0. X plus 3 equals 0. X minus 8 equals 0. Okay, now I just solved them both. And we're probably at a point where we can solve these in our head if it's a one-step equation. Okay, if it's, I got a minus 3 on both sides, so I get x equals negative 3 as one of my answers. This one I'm going to add 8 on both sides, so I'm going to get x equals positive 8 as an answer. And I'm done. Okay, last one. There should be two things you notice about example 4 right from the jump. One, it's in standard form. That's awesome. We don't have to move crap around. Anybody notice the other thing? Say it again. They're all even. Okay, the fact they all have 8s is kind of crazy, but they're all even. And the nice thing about knowing they're all even is that means we can factor out at least a 2. Can I factor out anything bigger? Can I factor out a 4? 4 won't come out of 18. Can I factor out an x? No, because it's only in 2 of the terms, not all 3. So I can factor out a 2 though. So I'm going to start by doing that. Okay, so see what I have left. 2 times 4x squared got me that 8x squared. 2 times negative 9x got me that negative 18x. And 2 times negative 9 gives me that negative 18. And I've still got this equals 0 in the back. All right, I'm going to factor the quadratic in the middle now. Okay, so that's going to look like this. I'm going to put my 4x squared here, and I'll start by making a guess. What should we guess multiplied by each other to give me 4x squared? Probably 2x and 2x, but we don't know. It could be 4x and 1x. I might have to go back and change that. Okay, let's get my other guy down there. Down in the right corner should be negative 9. I'm not going to worry about the negatives till the end. I would recommend that we guess the numbers closest to each other, so I would recommend we guess 3 and 3. And how I check to see if these are right is I fill in these two last rooms. 2x times 3 gives me 6x here. 2x times 3 gives me 6x here. Can I combine 6x and 6x to get negative 9x? No, so I guessed something wrong. Okay, would you like me to change my 3's to 9 and 1? By the way, will it help if I switch to 3's? No, because I'm still going to be multiplying them by 2x. So I could switch my 3's to 9 and 1, or I could go back and mess with my 2x and 2x, and maybe that's 4x and 1x. Any recommendations?
2x.
So let's change, they are recommending that I change my 2x and my 2x to be potentially 4x and 1x. So the way I check is I just check these two rooms. This bottom left room is now going to be 12x. This upper right room is x times 3, that's going to be 3x. Can I combine 12x and 3x to get negative 9x? Yes, I do.